Hi. Okay, for this lecture here on the families that we find on the periodic table, I will need you to prove that you've taken notes. So you'll either need to you'll need to write these down on a piece of paper, and then you have to photograph them, and you're going to put them on the OneNote page where I will have it set up that I need to see a copy of your notes here. So with that in mind, let's look at what we're going to be doing. The first thing you're going to need to do is you're going to need to print off, or if you don't have a printer, you're going to have to copy the blank periodic table. You can find that link in your OneNote page to either print it or bring it up so you can copy it. And you need to label once again all of the different parts of the table that we did before. So you have to put in the valley, you have to put down all of the period or row numbers, as well as all of the different numbers across the top, which are the group or family numbers. Remember, when you get over here, you need to have the 313 in. And then also don't forget to put in the break where metals, nonmetals, and metalloids are. So you basically just have to get this all set up so that you can fill it out as we go along in here. What we'll be looking at here are different families. The families are columns here, and we're going to be color coding them according to a pattern that I'm going to establish. So the first color code will be red, and that will be for the alkali metal family, which is column number 1. So this column will be shaded in as red, and then you will fill in the different symbols that belong to that family. The next color that we're going to use is going to be orange. Orange will be for the alkali metals, and they are in family number 2. And then for all of the valley elements, these are called the transition metals. They're going to be colored in as blue. Then we're going to skip way over here to 717. This is going to be the halogen family, and they're going to be colored yellow. And then we will have the noble gas family, which is family number 818, and we will be coloring that one green. So the colors that we're going to need are the following. So far you're going to need red, orange, blue, yellow, and green. And then the last color that we're going to use is purple, and that will be for the inner transition metals, which are this strip that's down here that really all fit on that little line between 6 and 7. So those are the colors that you're going to need to have available to do this. So for each of these different families, this is what I need to have notes taken. So with the alkali metal family, these are the characteristics that we find. They're found in the first column right here, column number 1. They all have one valence electron in their outer energy level. So that's one of the characteristics that makes them a family, is the fact that they have one valence electron. They are all metals, so they're going to be very shiny. They have a lot of luster, but they're soft. They're so soft that you could actually cut them with a butter knife. They're extremely reactive metals. They're so reactive that if you were to just put them into water, they would literally explode. And I used to do this a long time ago until the government took the metal that I used, which was potassium. They took it away from me, so I can't do it anymore. And then finally, these elements are never going to be found free in nature. You don't go dig up sodium or potassium. They actually bond so quickly with others to form things called compounds that we have to artificially separate them from the compound they belong to actually see the metal. The second family we're going to talk about will be found here. It'll be color coded as orange, and this will be the alkali metals. The alkali metals are again found in the second column. The characteristics that they have is that they all have 2 valence electrons in their outer energy level. They are never found free in nature. They're always going to be found in the form of a compound. And they, like column number 1, are reactive, but not quite as reactive as some of the other elements that are found in number 1. The next group that we're going to look at here is in the valley section. These are your transition metals. These are, again, all valley elements. The valence electrons vary, so there isn't a pattern here that they either have 1, 2, or 4. They can vary. It's usually between 1 and 3. These are the precious metals. These elements here are what we call precious metals. They're what you probably think of as when we talk about metals. So they could be things like gold, silver, copper, iron, and nickel. They do exist as just pure elements. You can actually go dig up gold and you can dig up nickel and find it as just the element. That's why they're considered precious. And they, these compounds of transition metals are usually very brightly colored. They're not always that silver color that metals tend to be. They do. So the next group that we're going to look at here, these will be the halogens. The halogens are found over here in column number 717. The characteristic with them is all of the members of this family have 7 valence electrons in their outer energy level. They're all nonmetals, of course, because they're found on that the right side of the break line on the periodic table. They're extremely reactive, and you can find these in all 3 different states of matter. So for example, fluorine's a gas, chlorine's a gas, bromine would be a liquid, iodine is a solid. One that I don't have on your list is astatine, which is also a solid, and so on. The next group that we're going to look at here is group number 818. These are called the noble gas family. They all have 8 valence electrons that are found in their outer energy level. They're all very non-reactive elements, meaning that they will never form compounds at all. So that's something to note later when we talk about compounds in our next unit, that you'll never find a compound that has a noble gas in it. They're also sometimes called the inert gases. And you can all find these in very small trace elements within our Earth's atmosphere. So literally you're right now breathing certain amount of helium and neon and xenon and argon, but they're very small amounts that you probably don't even, your body doesn't even really notice that it's breathing them in. The last group that you're going to color code will be the transition elements. These are going to be found, they're down here in this strip that gets pulled out of the periodic table. Sometimes they're referred to as the rare earth elements. There's 30 of them. There's only 2 that you have on your list. That would be plutonium and uranium. They're referred to as the lanthanoid and the actinoid series, since they're found down in this section of the periodic table. The first elements listed usually are lanthanoid and actinoid. They almost all are radioactive. These are where radioactive elements come from. And I would say about 90% of them are man-made in nature. Okay, which means that we've taken elements and we've forced them to become something else. Usually the way that that happens is through the bombarding of neutrons. Adding neutrons to an element will force it to become a different element over time. So now your job is to take the blank periodic table, label families at the top, and you're going to color code it according to this pattern. And then to submit it to me, you're going to have to photograph it and turn it in. Now, unfortunately, you're also going to have to do the metal one again unless you just happen to put that in your binder and took it home. You can just photograph it and turn it in. So when finished, I should see a periodic table that looks very similar to this for the family color coding, that you have put in the different symbols that are on our list in the correct spot where they belong. So it should be this, and they should be color coded. And don't forget to have a color code key that you're going to tell me that red means that it's the alkali metals, and that's family number 1. That orange means that it's the alkaline metals. That blue is the transition metals. Those are the elements found in the valley. And yellow would be the halogens, and green would be the noble gases. Whereas purple down here are these inner transition or rare earth elements. So one thing you don't want to forget is the key. Notes are also listed in your OneNote in a PDF format, or you can rewatch this video, which I'll also post back onto there. Okay. If you have questions, you're going to send me a remind so I can clarify. This will also be presented in a live Zoom that we will have on Tuesday, April 7th. Look for your email for the link to the Zoom.